Hello everyone and welcome to another episode on this very channel. In today's lesson, we shall be looking at a new topic altogether. We shall be looking at what we call the plane geometry tool, which is what the circle theorem, If today is your first time coming across my video lesson, don't hesitate to subscribe to my channel for more exciting episodes to come. Now without wasting my time, let's move straight to what we want to look at in today's lesson. Now, circle theory is one of the topics that students often dodge in an examination. Whenever they encounter a question of that very form, they mostly dodge. This is because most of them see the topic as very difficult one. But I bet you, if you really understand the concept very well, questions on circle theorem are very, very easy and then simple to solve. One interesting thing about circle theorem is that we don't do a lot of calculation. We don't do what? A lot of calculation. All what we have to do is to apply the theorems and then we are good to go. So in today's lesson, we are going to take the theorems one after the other. We learn how we can identify the diagrams. We solve examples on them. That is what we'll be looking at in today's lesson. So let's start with the first theorem. Actually, we don't have the first theorem, the second theorem, the third theorem. But we are using this as our first one, theorem. So in starting, all what I want you to do is to pick your math set. Now within the math set, you have this instrument, the protractor, the compass, and the ruler. I want you to take these three instruments. We are going to make use of them. We are going to use them to draw the diagrams for this theorem. Okay, so that we can be able to identify these diagrams whenever we encounter them in solving questions. So in looking at the first theorem, what I want you to do is to take your compass and then choose any radius of your choice. You can choose 3 centimeters, you can choose 5 centimeters, 10 centimeters, any radius of your choice, but it should be reasonable. Okay, so once you choose the radius, draw a circle. Use the radius to draw a circle. So I'm going to draw my circle like this. Since I'm not using any instrument, this is what my circle is going to be like. Now once you have this circle, identify the center of the circle. So this is my center of the circle. I believe you have seen the center of the circle that you drew. Now once you have it, take your ruler, draw a line to pass through the center. So let's call the end of this diameter as A. Let's call the end of this diameter to be what? B. Now the line that passes through the center of the circle is called the diameter. It divides the circle into 2 equal parts or into 2 equal halves. We call it what? The diameter. Now I believe you have this. Now once you have this, I want you to stand at A, that is one end of the diameter, which is A. Draw a chord. A chord means a line, so draw a chord from this end point to any part of the circumference like this. I believe you have it. Now stand at B also and then draw a chord or a line from the end of the diameter to meet the chord, this line that you drew. Okay, so we are going to draw a line to meet this. I believe you are having this diagram in your exercise book or your notebook. Now once you have this diagram, now let's call this angle, let's call this side X. Okay, so we have A, B, and X, right? What I want you to do is to pick your protractor, measure angle AXB. I believe you know angle AXB. Angle AXB. Most often, this is how questions under circle theorem are being given. Angle AXB. The letter in the middle of the two letters is the angle that you are supposed to measure. So it means we have to measure this angle. So use your protractor to measure this angle and then tell me what you observe. Now I believe you are saying that the angle at X or angle AXB is exactly 90 degrees. If you do an accurate diagram, we are going to get this angle to be 90 degrees. Now look at this diagram very carefully. This gives rise to the first theorem. It gives rise to what? The first theorem, which says that the theorem says what? The theorem says that the angle, this angle, a chord subtends at the end of a diameter to any part of the circumference is what? 90 degrees. Should I say the theorem again? The angle, a chord, this is a chord, subtending at the end of the diameter to any part of the circumference is 90 degrees. In short, you can say that angle in a semicircle gives us what? 90 degrees. So that is what the first theorem, that's all the first theorem is talking about. Now remember that the diagram for the theorems are not fixed, neither are they rigid. They can be drawn in any form or any direction. The only thing that you have to take note from the first theorem is that we have a diameter. We have what? A diameter. And then we have two chords subtending at the end of the diameter to any part of the circumference. So as I said, the diagram for the theorem can be drawn in any form. Now let's look at how the diagram for the first theorem can be drawn in different forms. Remember, we are saying this is what? 90 degrees. Now the diagram for the theorem 1 can be drawn in this form as well. We can draw it like this. So we have our diameter AB. Remember that AB must be a diameter. Okay, and then we have a center. Now we can draw it like this. A chord from one end of the diameter and then another end of the diameter. Since they are meeting at the circumference, the angle from here is what? 90 degrees. Now with the same diagram, we can also draw it in this form, or we can have it in this form. We have a diameter. Remember that this line must be a diameter. And then we have a line from the end of one end, a line from the end of the diameter, meeting another line from the end of the diameter. The angle created here is 90 degrees. We can also have something of this form. This is from the end of the diameter. This is also from the end of the diameter. The angle here is what? 90 degrees. We can also have it in this form. So we have the center. We have the center here, and then we have the diameter. All what you have to take note is what? Having a diameter and then center. And then you can also have it in this form. A line from one end of the diameter, another line from the end of the diameter meeting at the circumference. The angle from here is 90 degrees. You can also have something of this form. The angle created here is what? 90 degrees. 90. Sorry, let me write it off. Let me draw it off. So these are the various forms and ways the first theorem diagram can take. So when you see it in this form, the angle created here is 90. When you see it in this form, the angle created here is 90. The same thing applies today. The same thing applies today. I want you to look at the diagram for the first theorem very well and then keep it in mind. Now that we know this, sorry, we are going to take examples and then see how best we can apply the first theorem in solving questions on circuit theorem. The question that we are going to take is going to base solely on the first theorem. Okay. So these are some few examples that we are going to look at under the first theorem. This is our first theorem, that is theorem 1. So the question says that in the diagram below, O is the center of the circle. We want to find the angle marked with letters. So all those angles marked with letters, we are going to find it. And remember that all these examples falls under the first theorem, which says that angle in a semicircle gives us 90 degrees, or the angle a chord subtends at the end of the diameter is equal to 90 degrees. We are going to apply this theorem in solving these 4 questions on the board. So let's take them one after the other. As I said, take a critical look at the diagram very carefully. So let's start with this one. So we are saying that we have a center O, and then we have a line passing through the center which becomes a diameter. Okay, so we have the diameter to be what? AB. We also have a line from the end of the diameter and then another line from the end of the diameter meeting at what? The circumference. And from the first theorem, we see that when you have a diameter and then two chords subtending at the end of the diameter meeting at the circumference, the angle created there is what? Is 90 degrees. So it means that the angle here is what? 90. Now remember that in the diagram, you will not see this there. You have to apply the theorem that the angle a chord subtends at the ends of a diameter gives us what? 90 degrees. And then use that concept of theorem to find your unknown angle. So from this, we know that ABC is what? A triangle. Can you see? We have this triangle from the circle. A, B, C. And we know that this angle is 90 degrees. And then A is what? 30 degrees. And then this is what? X. And we want to find X. Remember that plane geometry 2 is an extension of plane geometry 1. So we are going to apply some of the concepts in geometry 1 to solve questions in geometry 2. So if you have not learned something in plane geometry 1, can you go back and then do some revision on that? So this is a triangle. We know that the sum of interior angle of a triangle is what? 180 degrees. Therefore, if we add this angle to this angle to this angle, it should give us what? 180 degrees. This is the diagram that I've drawn. ABC, triangle ABC is a triangle. So we can apply the sum of interior angle of a triangle. So we know that 30 plus this angle is what? 90 degrees plus X should give us what? 180. Now this is going to give us what? 120 degrees plus angle X is equal to what? 180. We are looking for angle X. So we just have to transpose this to the right hand side. We have our angle X is equal to what? 60 degrees. Very, very easy and then simple. As I said, with circuit theory, we don't have to do a whole lot of calculation. All what you have to do is to apply the theorems, and then you are good to go. Now let's look at example B. You can always pause the video and then you try your hands on them. So let's look at B. Now looking at B2, we have a diameter. I believe you can see it. So diameter is what? AB. It passes through the center. So AB is what? A diameter. Now we also have a line from the end of the diameter to any circumference, another line from the other end of the diameter meeting at the circumference. So from this, you can see that the angle created here is what? 90 degrees. Good. And this is what type of triangle is this? Triangle AB. Let's call this C. What type of triangle is triangle ABC? I believe you can see triangle ABC. Now let me redraw it here. Triangle ABC. So we have something of this form. We have A, B, and then C. And then we have these two marked lines. This angle is Y. This angle is what? X. We know that this angle is what? 90 degrees. Now this type of triangle is called what? an isosceles triangle. I believe you remember. Now with isosceles triangle, two of the sides are equal, and then the base angles too are also equal. The base angle, I'm referring to this angle. These two angles are called the base angles, and they are what? Equal for isosceles triangle. Isosceles triangle. If that is the case, or if the base angles are equal, then we can say that this angle is equal to this angle, and then this angle is also equal to this angle. So to find this angle, we are going to add this to this to this to equate it to what? 180, because this is what? A triangle. So we are going to have, since angle y is equal to angle x, this angle is the same as this angle, we can say that angle y plus angle y plus what? 90 degrees is equal to what? 180 degrees. So from here we are going to get 2y plus 90 degrees is equal to what? 180 degrees. We have angle 2y is equal to 180 minus 90. So from here we have angle 2y is equal to what? 90 degrees. We are looking for what? Y. So you can divide both sides by 2. Both sides by 2. This will cancel this. We have angle y is equal to what? 45 degrees. Now from here we have established that angle y is the same as what? Angle x. So we can also say that angle x is equal to what? 45 degrees. Very, very easy and then simple. Very, very easy. As I said, questions on circle theorem, they are very, very easy if you really remember the diagram for the theorems. Now look at this. I want you to pause the video and then try your hand on it. So with this diagram, let's call the diameter AB. So you can all agree with me that AB is a diameter, and we have chord subtending at the end of the diameter meeting at this at any point on the circumference. Therefore, the angle created here is what? 90 degrees. So to find angle W, we add this to this to this, equate it to what? 180 degrees. You know that this is what? 90. So we can say that 60 plus what? 90 plus W should give us what? 180, because let's call this triangle, because ABC is what? A triangle. Good. So this is going to give us 150 plus W is equal to 180 degrees. So you can say our W is equal to 180 minus what? 150 degrees. So we can say that our W is equal to 30 degrees. Very, very easy and then simple. Now let's look at the last one. Now look at the last one. I guess you'll be able to solve it. Should I leave it for you to solve it, or I should solve it for you? Now let's solve it together. I'll give you a try question, so don't worry. We are going to look at the last one and then we leave. Now looking at this, we have triangle ABC. Triangle ABC. And we also have what? AB to be the diameter, because O is the center of the circle. It was stated in the question. O is what? The center. Now, if you know that O is the center and then you have a diameter and a line subtending from the end of the diameter, another one meeting at the circumference, then we can say that the angle created here is what? 90 degrees. We can also observe that ABC is a triangle. Can you see it? ABC is a triangle. And in triangle, when you know two of the angles, you can find the third angle. So we are going to apply the interior angle of a triangle to solve this particular question. So we know that this angle plus this angle plus this angle should give us what? 180. Very, very easy to understand. So ABC is what? A triangle. And the sum of interior angle of a triangle is equal to what? 180. So you can say that angle V plus angle 50 degrees, let me write it like this, 50 degrees plus 90 degrees to give us what? 180 degrees. So we have our angle V plus this is going to give us what? 140 is equal to 180 degrees. we are looking for means, so you can transpose the whole of this to the right hand side. We have our angle V is equal to 180 minus what? 140 degrees. We have our angle V is equal to what? 40 degrees. Very, very easy and then simple. Now let me give you the try question, and then you can pause the video as you write the try question in your notebook or exercise book. So this is your try question. You can always do it at your leisure hours. This brings us to the end of today's lesson. In our next lesson, we shall be moving on to the next theorem. See you tomorrow. Bye bye.